Okay, last week we discussed about the physical addresses and the virtual memory addresses. Okay, so physical memory addresses mean it's the random access memory. The frames are the physical address. That means frame number, frame offset, entire things we call as a physical address. Then a virtual memory address that mean the page address that it consists of page number and page offset. So both addresses actually data set separately, and there is a frame number and page number. And the most important thing is the frame offset and the page offset. Both are equal. Frame offset and the page offset. If I take a different color. Okay, I'll take this color. So frame offset, this one, and the page offset, both are equal. Why? Here it's in the random access memory. From RAM to virtual memory, the paging file is moving. Okay, so the paging file is moving RAM to virtual memory as well as virtual memory to random access memory. Both the side. In such situation, the paging file is going to held, that means going to store in this frame offset. Then same paging file is going to move to the page offset. Therefore, frame offset is equal to page offset. Why? The same paging file is moving random access memory to the virtual memory virtual memory. Paging file means the program block. Can you remember the very first day we discussed program block? The same portion, we divide the operating system, divide the program into small same portion, same section, and that one section we call as a program block. This one program block, and another section, that means each program blocks are equal in size. We call it as paging file or as program blocks. This yellow color one. So these program blocks are equal in size. So that program block, or as another name, paging file, is moving to the random access memory for the execution. So if the space is not enough in the random access memory, it is moving to the virtual memory. So it's going to the page offset. So the place where I store that paging file is frame offset. On the other hand, page offset. Okay. Therefore, page offset is equal to frame offset. Both are equal in size. Okay. So then important equations, actually known into numbers. So I have taken these numbers just to easy for me to explain. So page size is equal to frame size. That is equal to page offset as well as frame offset. Why? The paging file, that means programming file block, is the one which is going to hold in this one, a page offset and the frame offset. So paging file is the one which is moving both the side, and therefore page size is equal to frame size. Another name, frame offset size, page offset size. So if this question is not given the value, so by default we take 4 KB. Total number of pages equal physical memory capacity divided by frame size. So total number of pages mean the full capacity of the full capacity of the physical memory in the random access memory, the full capacity, the capacity which allocated for the physical memory. Just imagine the capacity which allocate for the physical memory divide by size of the frame. Okay, divide by the size of the frame. Then we can find out how many frames are there. Then virtual total number of pages we can find out. The allocated space for the virtual memory, that is the capacity of the virtual memory, divide by the size of the page. Then we can find the page number of pages. And another important thing, frame size equal to page size. Frame offset is equal to page offset. I think it is in another equation. Frame offset is equal to page offset, also given in later. That means number of bit for the page offset is equal to number of bit for the frame offset. Both. Okay. I'll take that one also. Copy down this one. Number of bits in frame offset is equal to number of bits in page offset. Okay, so just look at if the equation is like that, we'll move the revision section. Which device generate the CPU, which device generate the logical address? We can call central processing unit is the one which generate the logical addresses. That means virtual memory addresses with the help of operating system. Which memory hold the logical address space? So logical address space is belong to virtual memory. So a device is CPU actually generate the address with the help of operating system. CPU generate operating system with the help of operating system. Operating system must be there. Then what are the two parts of the logical memory address? Logical address, page number. Another name we can say the virtual memory address, page number, and the page offset. Which memory have the physical address? That is random access memory. So what are the two parts of physical addresses? Frame address and the frame offset. So where is the page table situated? The mapping is happening the RAM which and each and every process has a page table. හැම එකටම page table එකක් තියාගෙන RAM එකේ frame එකෙන් කොයි එකද RAM virtual memory ගියේ virtual memory එකෙන් කොයි එකද RAM එකට ආවේ කියලා maintain කරනවා. What are in the page table? Page table consists of frame numbers which map the relevant page number. හරි අපි ටික ලියමු. අර ටිකක් ලියලා මේ ටික ලියන්න. ගානක් අපි ගොඩක් එකක් explain කරේ නැහැ. In a certain computer, physical address space is 4 KB. Just think, physical address space, that means entire physical address. This is equal to 4 KB. Logical address space is 8 KB. That means virtual memory address is 8 KB and the random access memory space is 4 KB. The frame size is 1 KB. So if one frame size is equal to 1 KB and that also equal to page size because our first equation, page size is equal to frame size. So find the number of pages, number of frames equal physical address divided by the size of the frame. So physical address space is 4 KB. one frame is 1 KB. Okay, so 4 KB divided by 1 KB is 4. 4 number of frames are there. Then next one, number of pages, logical address space. So logical address space is 8 KB and the page size is 1 KB. So there are 8 number of pages. Okay, so we'll complete these 3 slides. You need the formula. With the help of formula, you have to complete. Let's get started to copy the notes.